Hello everyone, good morning. My name is Jesus Aro.
My name is Ruben Arturo.
My name is Alma Cruz.
And my name is Jose Arturo.
We are students from UTR and now we are going to present for you what is a stepper motor and what is a servo motor. First, we are going to give you the general definition of each one of them and then we are going to continue with their configuration and also their characteristics, and we are going to try to explain you the principle of working of each. So let's start with the definition of the servo.
What is a servo motor? A servo motor is a rotary actuator or motor that allows for a precise control in terms of angular position, acceleration, and velocity, capabilities that a regular motor does not have.
Here we have the characteristics of a servo motor. Basically, a servo motor is an electrical device that is used in order to rotate an object, and also a servo motor has a rotation angle that varies between 0 degrees to 118 degrees. And in this image is showed an example of a servo motor in which one the VCC or the voltage is with the red color, the ground is with the brown, and the control signal is with the orange.
Now, configuration of servo motor. The first one, it controls of a DC motor gears assembled on a feedback. The next one is servo motor feedback control circuit, control the operation which compare the control signal PWM in a potentiometer. The next one is a DC motor shaft is connected to a potentiometer shaft through gear assembly. So a rotary DC motor rotates. And the next one, the last one, is at the same position of shaft. Both potentiometer signal and control signal straight match, which produce a zero error signal output.
Here we have servo working. Servo motor working is controlled by a pulse with a modulation of PWM and signal. The width of the control signal pulse is used vary a shaft position of the servo motor. Here we have it's a graphic, and you can see how it works depending on the signal. You can get this is the angular position. It is like 90 degrees, 0 degrees, minus 90 degrees, 0 degrees, and 90 degrees. And you can change it depending on the pulse that you are sending to the motor.
So now let's go with what is a stepper motor. A stepper motor is a DC motor that moves with discrete steps. The steps are defined by the phases of the motor. So if we energize a phase, the motor is going to move. So when we energize the phases in sequence, the motor is going to work. Now we have here an animated picture of the internal working of a stepper motor. So as we can see, this and this and this and these are the coils or the phases, and the rotor is represented with a gear. So each one of the phases are going to be energized and the rotor is going to start moving. So each one of the teeth of the gear is going to represent a step of the motor. Now in this slide we can see with more detail the characteristics of the stepper motor with the principle of working. So as we know, the stepper motor works thanks to the magnetism. So when we energize a coil, we generate a magnetic field. So we have two poles, which is a shoot and a node. So the rotor also have two poles, which is the shoot and the node. When the coil are energized, the rotor is going to move, trying to find its opposite pole. So if we have the north of the coil of the rotor here and the coil has the south here, the rotor is going to move in this direction. So if we energize pressurized now the coil A, the rotor is going to move trying to attract the opposite pole, because as you know, opposite poles attract.
Here we have the step angle. Step level is the minimum angle that a stepper motor can cover with what movement. Also, here we have an image that shows you how one step motor moves. It moves in angles of 45 degrees, and you can move it 365 degrees. Here we have the basic configuration of a motor, and in the image you can see here we have the two coils, and as my partner said, when the coils are energizer, make the rotor moves. This is like a general explanation about that. And the bipolar step motor has no center tap connection normally. It is of two windings, as you can see, is a bipolar stepper, and current flows through the windings, and it's a bidirectional in bipolar stepper. And here we have the other configuration is unipolar stepper motor and has a center. As you can see, a difference with the other stepper motor, we have a comb here, and this comb is for it just to make it like a unipolar and providing ground to the windings. Leads we can allow to flow current through each half and create magnetic poles and alternate poles sequentially. It can rotate according.
So, as a conclusion, we can say that this kind of motors are used for tasks where precision is needed, because, as you know, the servo and stepper motors work with signals that you send. They are going to move the degrees you want, the degrees you need, and also with the strength that you want.
As a conclusion, I can say that this type of motor can use in a specific situation when you need a precise movement of something, and could be helpful in industry.
As a conclusion, I think that this kind of servo motor is using in a specific task in order to help some objects or things to rotate.
As a conclusion, I can say that those motors are useful in the industry. Like the servo motors are used in robotics, and they can give you like the most precise motor, I can say. And yeah, it's the most useful motor for the industry.
So, do you have any question before we go with the game Kahoot? No?
We have a question for you. How many degrees does a stepper motor moves?
360. 360.
Yeah.
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 So, now let's go with the game.